What's up, you freaking geniuses? So in this video, I'm going to teach you how to find reference angles in degrees and in radians. All right, so let's start with this first example. Theta is equal to 300 degrees. All right, so what we're looking for in this case is theta prime, the reference angle, okay? So the first thing that we have to do is simply draw this angle that we're given, which is 300 degrees, all right? So here I already have my x-axis, y-axis, right? So but we're talking about degrees, so we can label this graph as 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And then if we go all the way back, that's 360 degrees, right? So again, the first thing we want to do is just draw this 300-degree angle. So starting from standard position, we're going to rotate 300 degrees, which is going to be approximately here, right? So a little bit past 270. Right? There's 300. Okay, now in order to find theta prime, the reference angle, you simply measure the distance from this arm that we just drew, or this angle that we just drew, the distance from this angle to the x-axis, all right? So this distance right here. Now notice I went the shortest distance, okay? Because we could have also gone from this angle that we just drew, right? We could have gone this way to get to the x-axis. But the thing is, reference angles are always acute angles. So you always want to go the shortest distance to the x-axis, all right? So in this case, this is obviously the shortest distance. So what is this distance in degrees? Well, we know this is 300 degrees, and then to get back to the x-axis is 360 degrees. So to get from 300 to 360 is 60 degrees, right? So theta prime, the reference angle in this case, would be equal to 60 degrees. All right, now let's go to this next one. So this time we have theta is equal to negative 135 degrees. So again, we're working in degrees, so we can label our axes again, right? 0, 90, 180, and 270, all right? So again, the first thing we want to do is just draw this angle. So this time we're going to rotate in the negative direction, right? Because this is a negative angle. So again, starting from standard position, we're going to rotate in this direction, all right? So this is 90 degrees. And then to get from 90 to 135, we're going to have to rotate another 45 degrees. All right, so we're going to be exactly halfway between 180 and 270. All right, so something like that-ish. So this angle right here, again, is negative 135 degrees. Okay, so to find the reference angle, again, we just have to measure the distance from this angle that we just drew to the x-axis, and we always want to go the shortest distance possible, which would be this distance right here. Okay, so again, this is theta prime. So what is that distance? Well, like I said, this angle right here splits, or it's exactly halfway between 180 and 270. So 180, to get from 180 to 270, that's 90 degrees. So halfway would be 45 degrees, right? So that means this angle right here is 45 degrees, and it means this angle over here, theta prime, is also 45 degrees, okay? And notice, let's make sure that doesn't look negative. Notice that the angle is positive. Theta prime, your reference angle, is always positive. All right, now let's just do these last two radian examples. So this time we're given that theta is equal to 2 pi over 3. So again, we're looking for theta prime, the reference angle. So one thing that might be helpful here is actually converting this radian to degrees. And I think that's helpful just because it's a little more intuitive to work with degrees, all right? So the way that you do that is whatever your radian is, you simply multiply it by 180 over pi, all right? So we're gonna multiply these together. So the first thing that you might notice is you're gonna have a pi on top and the bottom. So that's nice because those cancel out. And then the other thing that we can do here is actually reduce, because you might be able to see that we have an 18 and a 3, right? So 18 over 3 reduces down to 6 over 1. So on top, we have 2 times 60, which is equal to 120. And that's going to be over simply 1. And 120 over 1 is equal to simply 120 degrees. All right, so if we draw our angles over here, Okay, and then if we draw this angle right here, 120 degrees, it's going to be right about here, right? So this is 120 degrees, or in other words, again, 2 pi over 3. So again, the reference angle is going to be the shortest distance from this angle to the x-axis. So that's going to be this angle right here, theta prime, which is going to be, well, to get from 120 to 180, that's going to be 60 degrees. Boom. All right, now for this last one, we're given that theta is equal to 2.7 radians. So in this case, it would actually be easier to work in radians, all right? So let's label our axes using radians this time. So this is 0 radians, this is pi over 2 radians, this is pi radians, and this one down here is 3 pi over 2. Okay, so where the hell is 2.7 on here? Well, in order to make it a little bit more clear, it might be easier to plug in a number for these pi symbols, all right? So 0, again, is still just 0, but pi over here, we can actually just approximate it, right? So pi is equal to approximately 3.14, okay? So that kind of helps us. We have 0 over here, we have 3.14 over here. So that means 2.7 must be somewhere between 0 and 3.14, okay? That helps. What about this up here? Well, pi over 2, or in other words, half of pi, or in other words, half of 3.14 is approximately 1.57, I believe. Yeah, that looks right. So this is 0 radians, this is approximately 1.57 radians, and this is approximately 3.14 radians. So 2.7 is obviously somewhere between 1.57 and 3.14. It's actually closer to 3.14, so I'm going to draw it something like that-ish. Let's just say that's about 2.7 radians, okay? So in this case, the reference angle, again, is going to be the distance from this angle that we just drew to the x-axis. What is that distance? Well, how far do we have to go to get from 2.7 to 3.14? Well, we could just say 3.14 minus 2.7, and that's equal to 0.44. So this distance right here, theta prime, or we could say right here, theta prime, is equal to approximately 0.44. Boom. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.